golden age of tool changers is upon us, with several new models out this year already. And I think people don't realise how many new opportunities that brings to us. In this video, we'll explore a handful of techniques that you need to know about, and will hopefully give you some ideas of multi-material projects rather than just doing multicolour. That will be useful if you already have a tool changer or you're thinking about getting a tool changing 3D printer soon. Let's go. This video is sponsored by Sovol and their new M1D Idex tool changer, and I'll tell you more about that in a bit. The M1D is currently in the middle of its Kickstarter, which has been insanely popular, called it, raising $3 million. Didn't call that, in just a matter of days. You can check the links in the description to see the Sovol M1D Kickstarter for yourself. It turns out that if you have clear PLA or PETG, like this one I have here from Giantarm, that is exceptionally clear PLA to the point where I'm not sure I believe it's actually PLA. Anyway, I'll link it in the description. Light will somewhat internally follow the path of the filament, as you can see. Now that gave me an idea. I did a few tests in a few different directions with different configurations, and it's relatively forgiving actually in short runs of the clear part. What this means is that you can design a light guide to run through a part, and when you shine any kind of light source into it, it will light up at the other end. This is something that you probably already know. It's very common in commercial products. Pretty much every electronic product nowadays has some kind of light guide inside it. I'm surprised more people aren't already doing this in 3D printing, because it clearly works. In terms of design, you get a brighter output if you have the orientation of the lines in the direction you want the light to flow, and you get a more diffuse output if you have the direction of the lines perpendicular to the way you want the light to flow, if that makes sense. We've done this before with a whole video, or a good part of a video, so we won't dwell on it. I'll link to the video in the description. Supports for simple parts work pretty fine in most cases in single material, so don't just jump automatically to multi-material support. In most simple cases you don't need it. It doesn't really make a massive difference, but if you have a need for a neat underside, or you have awkward areas that absolutely need to be supported, then you can either use incompatible material support or dissolvable supports. The first one is usually some combination of PETG and PLA, although I found TPU and PLA can be used. The second option almost always comes down to PVA, because that's the affordable dissolvable filament. BVOH exists, but as far as I can tell, it's just really expensive and you're tipping it down the sink, so... Again, PVA, I've done a video on. You can go and watch that in its entirety. It's actually a really good video. I'll link it in the description. Once you have the ability to mix any materials on a whim, you can use that to design a whole range of compliant mechanisms. I've covered material interlocking several times now on the channel, but it's still a fairly hidden feature in the slicer and not on by default, so a lot of people still don't know it's there and they don't know what it does. Material interlocking is a really cool feature that literally interlocks by alternating directions of essentially fingers of each side of the filament boundary. So it's kind of creating a completely meshed structure. There is a whole paper on it. It's actually quite good. You can read that in your own time. Anyway, this method results in a physical bond between the two materials that's far stronger than you get with any glue. And so you can make just about any compliant mechanism that you want with this. Consequently, it's ideal for compliant mechanisms where you can have just one area on a model that flexes, just like the hinge on these boxes that I designed. And I will share this design and put the links in the same place as everything else. When printing with filaments like PETG and many TPUs, depending on your climate, it's important to make sure that the filament is dry. Sovol have sent over their SH03 filament dryer, which is a relatively good value solution to trying to get at least 4 filaments to feed from a dryer into the M1D printer. The SHO3 filament dryer has 2 separate lanes, one each side with 2 filaments in each, which means you can run 2 programs at once, which most filament dryers don't seem to do, at least as far as I have seen. I do have a lot of filament dryers here. And this is of course useful for when you have something like a multi-material tool changer, because it allows you to effectively keep all these materials loaded for when you need them, and you can dry them separately with different programs. And this is useful for something like a multi-material tool changer because it allows you to effectively keep all these materials loaded, not for every print, but for just when you need them. You can pick and choose which filament you want to mix. Because, as you may have noticed, with the bulk of these multi-material prints being more technical in nature, we're generally, in this video, not using more than 2-ish colours, maybe 3 at a maximum, even though the printer can do more. And this is also where the M1D actually comes into its element, because it's got the Idex function. If you're printing in only 2 materials, or predominantly 2 materials, whether that be the support and the part, or just TPU grips on a PLA part, and I do find that's the case, that I do a lot of prints in 2 materials, but when you're doing that, you can use the 2 sides of the Idex for a very fast tool change. If you don't include the time on the prime tower, which you probably should, but just for argument's sake, it makes for an effectively instantaneous tool change because the second tool is already there. I think it's an interesting setup with the Idex that opens up a faster way of printing when you need it, and it's good to have these kind of options on the market, to be honest. This one's a bit weird. A while ago, I reviewed conductive TPU by Recrius. It's probably about 2 years ago. But also, conductive PLA exists, and it's the same basic principle, even though for some reason I've never had any conductive PLA. It usually contains some kind of carbon, so it ends up moderately conductive, meaning it's basically acting like a resistor. And you can use it for, say, touch sensing, or with the flexible stuff, potentially flex sensing, because the resistance changes when you deform the part. And of course, with a multi-material printer, you can now thread these through a part, which opens up a whole bunch of new possibilities for sensing. This last one is pretty simple, and it's where you want to modify the behavior of a surface or part of a model to make it behave differently to the rest of the model. This could be anything from grips on a handle, that's quite a common thing that we see, to, say, a cup that fits over something that you might want to put some TPU inside to make it a flexible fit or to make it grip on whatever you're putting it on. Something like a cap on a pipe, for example. The advantage of this method is being able to get the surface effects that you want without sacrificing the rest of the material properties of the part. As you can see, there's a lot of potential here when you get to multi-material printing. And there were a few things I didn't include too. To name a couple, rigid bones inside of flexible parts, which would have been quite interesting to play with. Maybe I'll do that in the future. And mixing temperature incompatible materials, because tool heads don't need to flush between switches when you have a tool changer, so you can have materials working together, including interlocked with each other, that have vastly different print temperatures. And that's a whole thing that can be explored on its own. If you have any ideas yourself that I have not mentioned, and there's probably quite a lot of them, then put them in the comments and I'll note them down to look at in future videos if I can. I will see you next time. Thank you for watching.